Today we're going to talk about the SKR version 1.3, and we're going to do the TMC2130 SPI connection to our board. Now, a couple of things you need to know are that on this board, the actual circuitry is integrated into the board for SPI, so you can have your diag pin and also your end stop pins connected over here so that you can tell electrically when you've reached the end of an end stop. But for this tutorial, I'm going to leave off how to set up the end stop and possibly do it in another tutorial. I just want to get you up and running with these so that you can experiment. So the first thing you need to know is this is what the board would mostly look like when it first arrives for the BigTreeTech SKR version 1.3. I also have to tell you that I purchased all of the materials for this video with my own money, and I'm not being sponsored or paid to promote this, but I am going to put affiliate links in the tutorial so that you can find where to buy it, and also possibly to make back some money based on the money that I spent to make the tutorial. So to start with, we need to look at our jumpers. Now, it comes default with the correct jumper configuration for the TMC2130 with SPI. And I'm going to show you also a DRV8825 and how to configure that for contrast so that you can understand how to set these steppers, which I'll talk a little bit more about in a few moments. So first, what we want to do is we're going to install the DRV8825 on the Z-axis for our stepper driver. So I'm going to remove these jumpers because they're in the wrong position for this particular stepper driver. So now that they're out of the actual jumped position, I'm going to insert them where they need to be. So we have our MS1, we then have our MS2, and then finally we have our MS3. So as you can see down below here, as soon as I get this out of the way, they're on the jumpers to the right of where they once had been. And these are still covering all the red connections down below. So to install the actual stepper driver, which has an enable pin over here that you might not be able to see, but I'll show you closer in a moment. There's also an enable pin here that I've covered in previous tutorials, which I highly suggest watching. So you're going to line it up over the pins, and you're going to insert it straight down in. Let's do another one here for the Y-axis. It's the same process. And there you go. Now for the DRV8825, we have to find the enable pin, which is usually underneath. So we're going to rotate it over. And as you can see down below, there's an enable pin right here, so we just have to rotate it over and then place it in the port for the Z-axis. So that's all you have to do to set that portion up. Now for jumpers, currently we have all of our jumpers inserted for the SPI configuration, but we're not going to use them all, so I'm going to take them out for a moment because we're only using the X-axis and the Y-axis. So I'm going to remove all of them for a second so you can see which jumpers are required in this situation. So we're going to take the X jumper for SPI and place it right here. Then we're going to take the Y jumper and do the same, which is right next door. And that's all you have to do to set that portion up. Now, because this board is in the default positions for the jumpers, currently our USB connection won't work with our TF drive. So what we need to do is we need to move the jumper over to the next pair of pins. So you're going to have 3 pins and you're covering the 2 on the right with the jumper. Next, what we're going to do is we're going to connect the USB serial cable. So we're going to take the big side of the cable and we're going to connect it to the board over here, and we're going to take the small side of the cable, which is right here, and we're going to connect this to the computer, and you're going to hear a beep. Okay, I want to take a moment to talk about the BigTreeTech TMC2130. You might not be able to see the pins because of the angle, so I'm going to turn this for you a little bit. And so what I'm trying to explain to you right here is that we have pins that we can use right here for regular boards, but down below there's actually pins that are directly below it, so we can plug it directly into the SKR version 1.3 and not have to use jumper cables for our configuration. The cool thing about this board is that it comes with Stealth Chop as a native feature, so you can use current to control the stepping and also reduce the amount of noise that your stepper drivers will make. I'll show you that in just a moment. But you can also run an end stop off one of these 2 pins over here in order to create an end stop without using your end stops, thus freeing up these pins for another function. Okay, before we start, I need to point out the date and time here. So it's 10:39 p.m. last night. So what we're going to do is keep an eye on this in a moment. This is actually from the USB drive for the TF drive on your SKR version 1.3. We're going to go over to Atom now with PlatformIO loaded. And the way in which I loaded this is I downloaded a copy of Marlin Firmware from the website for version Marlin Bugfix 2.0.x. I unzipped it, and then I went over here to Open Folder and opened up the unzipped folder. That'll give you all of this so that you can work with it. Now the next thing that we need to do is set up our actual correct board type. So we're going to go to the SCR folder or source folder, then we're going to go to the core folder, then we're going to open up boards.h. Inside boards.h, we're going to do a search on SKR, and we're going to copy board underscore BigTree underscore SKR underscore V1 underscore 3. Then we're going to close out of boards.h. We're going to go up a directory, then another directory, and we're going to open up configuration.h. Inside configuration.h, we're going to do a search on motherboard, and we're going to replace board underscore ramps underscore 14 underscore EFB. So we're going to paste our copy right here. And then we're going to scroll up and we're going to change serial port 0 to -1. And then we're going to search on A4988. And what we have here are all the possible drivers for stepper drivers that you can load on the SKR version 1.3 from Marlin. Not all of these obviously are possible for this configuration, but they are possible within the Marlin firmware. So we're going to remove the comment for the X driver type, the Y driver type, the Z driver type, and we're going to do E0. And because they're all defaulted to the A4988, which has 1/16 of a step, we're first going to replace the TMC2130 for the X and the Y. Now, because we have a DRV8825 that does 1/32 of a step, we're going to copy that and put it on our Z stepper. And we're going to leave the last one alone because we're currently not using it and just uncommented it for good practice. So I need to review a couple things. First of all, the TMC2130 can do stepping between 1/16 of a step and 256th of a step. But for now, we're going to leave it at 1/16. So we're going to search right now on default axis. And what we want to do is for the default axis steps per unit, we have the options for X, Y, Z, E0, and then additional extruders if you so choose. But seeing how we're using the DRV8825 on the Z axis, we're going to change that to 8,000 because it's twice the normal steps of the A4988. And that example can be applied also to your TMC2130s later on if you so choose. Now we're going to go over to the configuration.h tab for the advanced configuration, and we're going to do a search on 800. And what we have here is the current that we can use that's defaulted to 800 milliamps. Now, in order to configure it to the correct stepper that you're using, you're going to have to go to your data sheet and see what the peak current is. But you're going to multiply it by the root mean square, which is RMS, and that's defaulted to 1.414. So in this case, I'm just going to change this to 600 for the example. And then I'm going to do the same for the Y as well. And keep in mind that if you want to change the number of steps that your stepper driver can do, currently it's defaulted to 1/16 of a step. You have the option to take it to 256th of a step. So let's search now on TMC use software. And what we have here is we want to use the software settings that we set up in our pins file that come by default inside our Marlin download. So I'm going to show you real quick where that's located so you can see them. So if you go to the source folder, and then you go to the pins folder, and then you go to our chipset, which is the LPC1768, you'll then see that we have the BigTreeTech SKR version 1.3.h for your pins folder, so you can open that up for your pins file. And inside here it shows what all your pins equate to on your board. So if we scroll down a little, we can see that our chip selects are already pre-populated for us, so we don't have to worry about these. So I'm going to close out of this and go back to configuration advanced.h, and we're going to search on monitor driver, and currently it's commented out, so we're going to remove the comment so that we can eventually use the G codes up here. And we're finally going to search on TMC _debug, and we need to remove the comment as well for this so that it's defined TMC _debugging, and that'll allow us to check the status of our stepper drivers for the TMC2130 with SPI configured. So I'm going to show you a couple other things real quick here. We have the ability to set the sensitivity for our overcurrent when we reach the end of an axis. I believe down in the value of 8, meaning like 2, will make it more sensitive, and raising the value to like 16 makes it less sensitive. But that's documented someplace in the firmware in here. But to actually set up sensorless homing, what you're going to do is you would remove the comments, but in this case I'm just showing you how to set up the SPI steppers, so we're going to skip that. And then I also want to show you that we can do hybrid threshold if we so choose, where we can set an actual number for the speed that's greater to increase the speed of the printer, but it will increase the noise level. And then over here we have a couple other things I want to show you. Right now I'm not going to comment these out because we're currently not using them, but I'm going to leave them uncommented. But you can disable stealth chop if you don't want it to be quiet, and it'll default to another mode. So now we need to set up what's known as our PlatformIO configuration file, which is called PlatformIO.ini. So I'm going to click on that, and right now it's defaulted to another chipset, which is the NEMA17 So we're going to scroll down here and we're going to find our chipset, which is the LPC1768. So we're going to copy that. We're going to scroll back up to change our default environment from the ATmega2560. We're going to paste ours over it. And so next what we're going to do is we're going to press the upload button, which will upload our changes after it compiles. So here we go, and we'll click save. Okay, as you can see, now in addition to firmware for the cursor file, we have a new file that was recently generated called firmware.bin. As you can see, it's got today's date and just a few minutes ago. So what I'm going to do is I'm going to remove the USB drive in a second and show you what happens. But before I do that, I want to show you an atom with PlatformIO that we can check that we have a good build. So if you go to PlatformIO, then to toggle build panel, you can see that it says succeeded. And if you scroll up, it'll actually show you that our particular configuration actually succeeded. So I'm going to toggle that back down so you can see it. So it's toggle build panel. And I'm going to go back over and I'm going to remove the USB drive that's connected to the SKR version 1.3. Now I'm going to reconnect it. And as you can see, the time has updated to the time of the bin file, and the firmware now is updated. Okay, currently I have connected the power supply and steppers off camera. So you can see that the voltage is red and the black is ground for the power supply. It's currently disconnected. Now we're going to connect the cooling fins for the TMC2130. Now when I had you move the USB to power off USB, I need you to move that back to where it's power on the other two pins in order to make this work. Next, we're going to connect the USB connection that's already connected to the computer to this end being the TMC, or excuse me, the SKR version 1.3, and then I'm going to connect the power. So keep in mind, you don't want to touch this with your hand once voltage or load is running through the system, because you don't want to damage your board. Okay, now I'm in the print run directory for Pronterface. I'm going to open up Pronterface. I'm going to connect to the SKR version 1.3. And as you can see, it said connecting, and now it says printer is online. So we're going to check to make sure that the steppers are okay by typing M122 and pressing enter. And as you can see, they say testing for the X and the Y is okay. So next, we're going to step the X-axis 100 millimeters to make sure that that works. So here we go. So notice how quiet that was. Now we're going to do the Y and see how quiet that is as well. And then finally, we're going to step the DRB 8825 on the Z-axis and see what that sounds like. So if you like my tutorial, please press the like button and subscribe, and thank you for your time.